Welcome to this webinar where we'll go through the footbridge designed in SDS2 and then brought to SCIA through autoconverter and then uploaded back to Beam+. The merge between SCIA, Allplan, Freelo and SDS2 didn't only bring really nice product close together, but also bring us expertise and especially new accents. So I'll present to you today Javier, that is a civil engineer from Allplan España, and he will present us today SDS2. Javier is a civil engineer specialized in infrastructures, where he developed most of his career, and now is part of Allplan España as technical specialist. Michele, you know me, I am responsible for the engineering part of the technical support, and I'll present to you today the autoconverter tool, how to import and to create from SDS2 an analytical model. Go to webinar. The webinar will be registered. You can ask your question in the proper box. Today we'll go through a first part in which Javier will present the modeling of in SDS2. Important to notice the automatic connection, handrails, plans, measurement, and then the export to Beam+. I'll take over from there with the import to autoconverter, the alignment, export through the SAF format to SCIA, where I run a small calculation. I'll show how the import went, and then I'll upload it back to Beam+. SDS2 is our steel modeling tool that has main important features like fully customizable configuration, automatic connection, not only the modeling part, but then also a regulation-based connection design, so the checks, and then also the verification of the buildability. So the main benefits are reassumed here. The results are automatically adapted to the manufacturing preferences. So as you can see on top, is a tool capable of converting a beam model from LOD 300 to LOD 400, making your life much easier to fabricate steel structures, create connection faster, and also manage part marks and from model to drawings. The workflow, you know it already. We are open beam. We work with IFC. We work with SAF model. We work with ASF models. So today we will see the IFC upload from SDS2 to Beam+, then switch to autoconverter where the SAF model is created. What is SAF? Structural analysis format is an Excel-based editable sheet that contains most of the relevant data, so geometry, material, coordinates, and as I said before, is fully editable and is supported by the major calculation software. Without further ado, Javier, the floor is yours.
Okay, thank you so much for your introduction. Yeah, let's go. Let's see what can we do with SDS2. First of all, I would like to introduce my pedestrian bridge. Okay, here we can see that there are some parts that are missing. For example, this rail that we are going to model later, or these two beams. Okay, that's what we would like to do. What we are going to do, we are going to model this kind of a structure of elements. Okay, for that we are going to put a plan view. Okay, where we can see part of the bridge, but yeah, just clicking here we can see everything. Now let's see this part where the two beams are missing. Yeah, that's the way we can model here. We are going to do it later from this plan view, okay? But I would like to show you something more intuitive sometimes. That is that we can model from the 3D view. For example, we can choose a beam, okay? We have a catalog of a lot of profiles, okay? You have different filters, okay? You can choose a pipe, these different kinds of profile, like an angle, okay? We are going to use this one. We can configure everything, but also we can configure this, what I'm showing you, the kind of intersection that we are going to use to select from where to where is going to be link the beam. Here we have this option, this automatic recognition, let's say, where, look, when we approach my mouse to the element, it will recognize automatically where should put the beam. Okay, in that case, just click here or here, and now SA to change it, a combination of the keyboard, just to make it solid and show it. Take a look, pay attention that the connections are automatically created. That's the important thing. All the connections are automatically created. And it is very simple. Okay, you just create the beam, you just need to model the elements you want, and the program will offer you a connection. Quite simple. Okay, of course you can configure everything. You can say what you want. If you want to connect, for example, the web to a flange, for example, let's say the web of a beam to a flange of a column, okay, you can configure let's say the most common connection that you have. So every time you use this kind of connection, the program will offer you that. But not just the automatical connection, okay? You can also choose manual connection. You can edit all the connection. For example, here we are going to put thin plate connection, okay, for preventing shear. Look, we have it in the right part. We are going to move the model like this, and we can see here this thin plate connection. Okay, as you see, we can put it, we can select. Of course, we can modify it. We can now, I'm going to change it again to auto standard. That was the one that I had. But you have to know that we can modify all the connections. Okay, but not just modify, we can also obtain a report of the calculation. Okay, we can have, for example, here, I'm going to save it. Okay, and it is generating it. Now we are going to open it. Give me a second. Yeah, here it is. Look, there is, okay, a report where we can see all the information of these connections. Okay, the report is of the two connections from the left and the right side. Okay, but we also have this expand calculation report. Okay, where we are going to see also all the calculation, let's say step by step. Look, okay, same information, but now we can see, let's see a little bit down here. We can see all the calculations there and how the program checks every connection, every bolt, every weld, okay, is going to be checked. So we can add this to our calculation annex in our projects. Okay, so yeah, easy to use, easy to manage then all the results, and as I said, easy to work on it. Great. So now we are going to see how we can model a handrail. Look, we are going to go to plan view as before. Okay, this that they call tablero. Okay, it comes from Spain. It's the deck of the bridge, and from here, yeah, just click here to see everything. And now we are going to create a handrail from there to there. Okay, let's choose the option. Okay, and let's focus on this point. Of course, we can use the magnet as before, just to, okay, select the exact point with the structural element, okay? But now we are going to use the intersection between two construction lines, okay? Two construction lines, a grid that we have already created, and we are going to use it. But what's the problem? If we use that, we are going to create the handrail right on the line, okay? And it will be created exactly on the web of this beam. Something that, of course, I will not want to have. Okay, I don't want to have it. So what can we do? We can apply an offset. For example, here I will apply 70 millimeters to the left, and look how the point is right now 70 millimeters. So it has a 70 millimeters offset from the place where I click. Okay, I have already clicked here, and now we are going to choose the second point. And also I will add a new offset, but now in a high point. I will, let's say that this point is 2 meters down from here. So I click, the red line is already created. I'm going to delete these values because it has memory, the program has memory to remember it, and automatically I will have this window. Okay, on it I will see all the properties of the handrail. It's very easy to use. We are going to see it. We can change the type and so on. We are going to do it right now. But just say OK, and let's see how it is created. Look, there's a bad connection there, but we are going to solve it now. Okay, we can see that this handrail is absolutely different from the others. Of course, we can overput one and the other and see that all the posts are not in the same way, not the same distance. So we have to change little things, and we are going to see how easy it is to modify this kind of handrails. For example, we are going to change the style. Okay, we are going to say that the style is mesh. We are also to delete the toe plate, you know, this plate that we have in the bottom of the handrail. Yeah, we are going to say OK, just to see how it is working little by little. Okay, let's see how we are modifying everything. Okay, here, and we have it. Of course, it is not the same. What we are going to do right now is to click on one that we have, okay, and see which parameters do we have here. For example, here we can find all the information about the connection. We can see that it's a base plate. Okay, we can see here also, we are going to see where it was. Okay, the rail, the lowest rail, the height of it. Okay, again, the height of the lowest rail. And also we can see how the posts are located. They are automatically located every 1 meter and 250 millimeters. Okay, and also the ends. The ends, you can see that are different. So those are the things that we are going to change right now in our handrail. For example, the ends, we are going to say that it's a kind of, it's type PN. We are going to modify the distance between posts. Oh, I click on enter, sorry, it's calculating it. Okay, done. Okay, the posts are right now and the ends are okay. And we only need to change the height of the lowest rail. Okay, we are going to say 150. Okay, and we have it. Now we have the handrail done. Okay, we see that's the same. Maybe we can modify something else, but it is quite easy also to manage this kind of elements. Okay, great. So, what's next? Yeah, what we are going to do right now is to see how can we model, okay, anchor bolts. Okay, here we can see that we have already modeled some base plates for all those columns. Let's focus on these base plates. Okay, we can see that the holes are already created, all of them. What we have done is to set up first how the base plate is, okay, and now we have to say where the anchor bolt is, okay, just to join, let's say, the column with the foundation. Okay, we choose the tool. Now we only need to choose those columns that have this base plate. Okay, we are going to choose these 8 columns, right? Now right click, okay, and it will start working. Let's put first a good view just to see how the program creates every anchor bolt. Okay, right click and set, okay, and here we have the configuration, or here we have the window where we can set, okay, how the anchor bolt should be. As we see, all the files that we can complete, okay, we are going to complete them with those values, and see that when we modify some of them, okay, another fields appears in red. What does it mean? It means that all the measures should be correct. If there is something that is not logical, okay, the program will advise us, will say, okay, you cannot do that with this red color on the file. Okay, when we have everything set, when we are sure that we have it, we can click in OK, and we will see how the program creates every anchor bolt right in the hole of the base plate. Okay, quite easy. So yeah, we can create also these anchor bolts from using SDS2 on an easy way. Great. Let's continue now with the drawings. Okay, I'm going to show you how we can manage all these drawings. And for the first step, let's say, we have to export all the content to the drawing area, let's say. Okay, we are going to export plan view. Okay, we are going to export let's say a section view. Okay, for example, for that we are going to put ourselves on this plan view that we have already used. Okay, and now we are going to click here just to export this. Here we will have the different views that we have created, for example, this plan view and also this section view. Okay, we can choose both of them. Just click on OK, and here will appear a new window where we can set up all the configurations that we want to export. How we would like to see the structural elements, as stick, as wire, solid and wire, solid and stick. Okay, a lot of things. How the annotations will be. Okay, all the text that will appear in the drawings, and also we have some configuration for the piece marks, but we are going to talk about them a little bit later. Okay, when we have everything, I'm going to leave it as you can see it. We click in OK, and the program will export it to the drawing area. Okay, easy, fast, and we will have that on the drawing area, as I said. Now that I have exported everything that I want, I'm going to show you what a piece mark is. Okay, for that, I'm going to go to display, toolbar, okay, oh, sorry, it was the bottom next to it. Okay, and active member piece mark. What's that? Look, if we go here, we see a lot of codes. Okay, what does it mean? For example, this one, B191. What's that? That's the name that the program gives to the element. And it is a single name. No any other beam or any other column has this name. Why? Because there is not any other beam like this, with the same holes, same connections, and everything like this. So, in the case that we have two elements with the same names, that means that those elements are exactly the same. Okay, what we are going to do is to export it to the drawing editor. Okay, and let's choose simply the name. All of them are blue because we have not sent it before. Okay, I select B191. I say OK. I set up all the options that I would like to have. Say OK. And just 1 second, it is done. Right? Okay, it could be done, but we are going to export another one. Of course, we could do it twice at the same time, let's say, but okay, let's see how the element B191 is now black, not blue, because it's already sent. We are going to choose the element B357, and that's okay. It is sent. Now, what we have to do is go to the drawing editor. We have here the tool, we can go it fast, but also we can choose it from the home screen. Okay. Well, now that we are here, we can see both of the elements that we have exported, and just clicking on it, we can see this view. Okay. This is not a standard view. Would mean is that we can modify everything. We can choose the different levels, okay, and we can modify. We can change everything we want, the position, also all the text that we have, all these quotations, okay, that we have. For example, here I would like to move the line. I don't want to move this 70 millimeters, okay. I would like to measure from here to here and so on. Of course, we are not going to save that, but we can change text, okay. Just double click on it. And for example, I would like to put this one in Spanish, okay. Let's remember that it was a Spanish project. It's okay, but not just this, B/191. Yeah, we have it. If we want to keep it like this, we can save it, and that's all. But not just this, because let's say that we have the quantities, we have a bill of material. That means that we can see all the elements, all the components that are inside this element. Okay, for example, there is a beam of this profile. We have here all these bolts. We have everything here. Point by point of the which elements, which material do we have in the element. Okay, I can save it. I would say not, and let's see how it works, because now we have also these plan views, okay, that we have selected. We can see that, yeah, we did it quickly, and there are a lot of things, but for example, this section view, okay, we can see that it's better, and we are going to, I think that we are going to use it better. Okay, when we have everything, of course, I can add here levels, I can modify whatever I want, as we have already seen. Okay, we have to put this, let's say, put this view inside a template, okay. We have different templates depending on the size of the paper, okay. For example, this one of it, where we can see that the program will automatically add all this material, okay. But for example, we have something bigger. Which one was? Yeah, this one, I thought. Yes, where we can, for example, put here plan view, or this cross section that we have done, or for example, we can add whatever we want. Okay, so let's create something like this. I'm going to create a direction sheet. Okay, I just put the name. Sorry. Okay, and choose the template. We can configure, we can set these templates. Okay, we can manage it. It's not a problem. Now we have to add the view that we have already created. For example, I'm going to use this section. Okay, I just need to click where I want to put it. Okay, here. I don't want anyone else. I could, okay, but I don't want. Just click on it. We can modify it. For example, the scale. I would say 0.2 maybe is too much. Okay, 0.15. No, not enough. Little bit bigger. Yeah. Yes, better. And now, of course, we can select it. Oh, not like this. No. Give me a second. Okay. Click on it, yeah. And I can move it. Yeah. Just like, okay, I would like to put it higher in the sheet. That's it. And I will have it. Okay. That's my first sheet. Okay. Easy to do. I think that we don't have any problem with that. We can configure everything. We can set up all our templates and use them for this. But let's think that for the members, it's not the same. For the members, we have a lot of beams, for example, and I would like to do it automatically. Okay, I will click here. Okay, so you can, and I only need to choose the template of the sheet. I can, of course, configure everything, how I want to see my layout in the end, the scale, and so on. And when we have it, we click OK. Okay, which elements do you want to have? I will choose both of them. And it is done. Let's see them. I don't want to, yes, I want to save it. And now I have different elements. For example, detail sheets. I can see that I have two. What does it mean? Look, here we have the view that we already created or modify, okay, with all the bill of material there. The two kinds of beam that I choose, okay, I have automatically the layout for these elements. And of course, we can use this tool, the automatic creation of layouts for all the elements that we have. So it will be quite easy to have all the layouts and all the drawings of the project. Well, now that we have the 2D drawings created, I'm going to show you here from the home screen, okay, all the options that we have to export our model or to export our 2D drawings. For example, for things PDF, of course, all these 2D drawings, we would like to have them on PDF, but not just PDF. We can also export to CNC. What does it mean? It means that you can export all your 3D model into the shop. Okay, so in the shop they can create all the steel, they can cut it, they can do everything from here just with a simple file, okay, that we can, as I said, we can export it directly from SDS2, right? But also we have also in a beam situation, okay, we can export the model into IFC, for example, to collaborate with another softwares. As you know, we are going to pass the project to SCIA later, but right now, for example, we export it to IFC, and let's see how we can see all the model and complete it, maybe with the foundations and so on, in our plan. This is how we did it with IFC, with an IFC file. Okay, just to mention it, that we can do this. Great. Okay, back to SDS2. What we are going to do right now is to upload our model to BIM Plus, okay, where Michele will do his magic. For that, I select my project. Here we have it. We're going to view everything like this. Great. And for uploading it, we only need to go to Toolbox in the action bar. Okay, here we go. And here we have the icon to upload to BIM Plus our project. We only need to select all the elements that we would like to upload, like this. Okay, with a simple box. Right click, okay, and choose everything. First, I need to log in into BIM Plus. Okay, I was already logged, so quick. I choose my team. It's okay. I choose the project where we want to upload it. We cannot yet. Okay, drawings. I don't want to export drawings. Revision. No. What's wrong? Let me check. Okay, here in project I have to select the model. Okay, upload. Easy. But we have to wait just a few seconds and it is done. Before we go to BIM Plus and see the project there, I would like to show you that we can also export and import, okay, this 3D model into a SAF file. Quite easy. Okay, we can click on it. We can also import and obtain the, let's say, this file that we can manage in Excel, for example, or very simple programs. Okay, and why we don't do like this? Because I think that all you know that it's important to process this file later, and the best place is BIM Plus for that. Okay, so let's go to it. Here we are, BIM Plus. We have here the model, okay, with all its connections, with everything, all the information, the difference. For example, this handrail have all the attributes that we have added to it. And yes, that's all. We have here the project, and now is Michele's turn. Okay, I just want to say thank you so much to all of you for attending, for paying attention. And now, as I said, Michele, it's your turn. Thank you so much to all.
Thanks again, Javier. So we'll go through BIM Plus, where I received the model, and I'm gonna open it in BIM Plus first, where we can see the structure. And then I'll go back to BIM Plus to then move to AutoConverter. So now AutoConverter recognized the same folder. So here I can show exactly the same model, still IFC base. And then I can already filter part of my structure. So as you can see, there are some part of connections, some reinforcement, base connection that I actually want to remove, the handrail as well. So I can already hide part of those. And then, for example, if there are groups in which there are both structural and not structural element, I can just select them. There are some information that I can use to filter, and then I can hide them from the model. So they are still there, they're just not used for the conversion. I can always go back and select them in a second revision or if needed. So, but at the moment it doesn't concern us. So I'm gonna continue cleaning a bit the model. There are some elements that I can see only in the transparent mode, and also I have the bolts that I want to remove. And here you can see that I just need to select the option bolts, easy to filter, and as mentioned, I can save this view. I can always go back if there are other elements that I want to remove from the view, I can always do it. So then this is my first test of alignment. Okay, it would just be one in this case. And here I can see the different element and I can decide how I want them to be recognized. So either I can decide to be recognized as a 1D element or a 2D element. Cross-section are also recognized automatically, and if there are any that are not recognized, I can go through the library of SCIA, or let's say of Nemetschek, because that's a general library for cross-section, and then I can select the correct type. You can notice that when I select one of those, the other one is recognized automatically. So it goes through the library and understand really what I'm working on. I can select the element. I can actually also decide to create sort of groups. This group, I will use them to align my structure later. And also this type will be recognized in SCIA, so I can use them also to filter my model. So this is a part of the work that I'll do really quickly here, but notice that is something that it's not mandatory. It will help you in a second time to align the structure. I'll go through the columns. If there are any specific element that I want to avoid, I can still add them to a group. And then, for example, there are a couple of elements that are not columns. So these four. And then I can just select them and add them back to another group. Check 1 second that everything is fine. And then I find this latest group. So this group rafters and columns, I will use them then to align my structure specifically. Now I can recognize the model. The model won't be aligned, but now every element is recognized as an analytical element, and I will see the results of the recognition. And here is actually where in most cases you start having the problem, because the model is not aligned and the element, the nodes are not connected. And here is where the magic happens. Okay, so there's where the groups that I created come handy, because I can force this group to be freezed in some direction. So I want, for example, that my rafters will be blocked in the y direction, so they cannot move from their axis, let's say, but they could be moved up and down to follow then what to follow then the position of the column. Position of the column that will be blocked, and the column can only change in the x direction, so be reaching, let's say, the different floors. So that's the only movement that I want to allow. And for most of the beam is just in the y direction. So still the possibility to move up and down to find the right alignment with the column and with the main beams, here called rafter. Once that's designed, I go through the alignment, and there I can also align by group eventually. So I can decide, for example, to align columns and rafter as a first option. So these are now aligned, and then I can run the alignment between the other type of elements in a second time. So now you see already that there is an alignment of the column and the rafters, okay? And then I can run the alignment of the rest of the model. Now I have three models here. I have the structural model, I have the recognized model, and then I have the align model. So as you can see, the align model is now the model fully where the nodes are consecutive, where there is no distance between elements. Now I save this model, I create a new one. That's saved in Beam Plus. And from there, I can see it as an analysis model. So every step that I take are already, we can see them here and can be saved. And here I can also export it as IFC. Then from out converted directly, I can instead go through the export as a SAF file. Here I select my aligned element, aligned model, and then I can export it to SAF. So here you go. After now 15 minutes that we are here together, I have a structural model that I can import in SCIA. So it didn't take that long. In my, let's say, video or post online, I mentioned that it took a couple of minutes more. Now we'll see a bit the reason. So import my model now. Here it is, everything recognized. We have the possibility to go through the type to filter the model. I can show it just to make sure that everything is fine, that all the cross-section are recognized correctly. Eventually, I can check if there are any specific layer that I want to create. And then I can also show, for example, the color by cross-section. So then we can easily go through the different cross-section in the model and have a look at those. So as I mentioned, the model still took a couple of minutes more to align. There are some elements that we need to double check, okay, that they are fully connected. And there you can see that there are some points that I can use to align. The nice part is that in SCIA also the manual alignment is quite handy because I can just select one element as reference point. Now my new coordinates, center of coordinates is along is like the local system of the beam. So I just need to change the coordinates in the y direction, and the nodes are directly aligned. I can also see here there is a small gap. So what I can do is create a dummy element, for example, or I can have a look at the distances, and then what I can run is the connect elements nodes, and in that sense I can select the element that I want to connect and create an automatic rigid link. So here is quite easy as well, and to create and to align and the model. So I do the same on the other side, and then the model is done. As mentioned, took 25 minutes to create a structural model. To run the calculation, I just go through the introduction of the supports. And then I just enter the load case, and the self weight is created automatically. So then I can run my calculation. Calculation is done. I go through the visualization of the deformation, and I can have a look to hide the analytical model to show you the deformation, both in linear and eventually also in 3D. That is a nice overview of how the structure behaves. I go back to my structure. I'll show it again. And then I'll activate the dynamic analysis, and in particular the new vibration analysis, to show you a bit how it works. There is a dedicated webinar. There will be dedicated trainings as well this year, if you are interested in that. How to create some loads. I will just add like the load corresponding to the presence of the people. So variable load, 5 kilonewton per square meter, and applied. Already with that, I can create my combination of mass so that I can run modal analysis and find the eigenfrequencies. And what I can also have a look at, if I just want to focus, for example, on the vibration in the Z direction, I can go through the solver settings and decide to analyze the mass just on that direction. I'll have a look at the calculation protocol, and then it is here that I can see that I have modes only in the Z direction. And in particular, the first two modes are the one with the major mass, and I can have a look at that shape. So these are the frequency, for example, that I want to cover, and I can create a load case where I go through the range of frequencies related to that. So here you go. And then I can set the range of frequencies that I want to analyze. So from, for example, 1 to 3, I can change it, and I can go through a step of 0.1, for example. And it will create all the loads, so all the 20 load cases. Okay, I won't go through that now. I'll just show you the modal shapes, and then based on that we can run that analysis. So as mentioned, there is a dedicated webinar. There will be training on the vibration analysis, so you can follow on our website for the dates, or you can ask to our support. I'll show you the video, the vibration of the Footbridge. And as mentioned, so we are here in 40 minutes. We really pass from modeling to analysis, and now we go back to Beam Plus, where I can also share and export the results. So I'll create my structure. I need to give it a name. I'll call it revision 2. Thanks to all of you for attending this webinar. I hope it was interesting. If you have more questions about SDS2, about autoconverter, about SCIA, about the vibration analysis, we would be happy to answer to you. So thanks again from myself and from Javier. We wish you a really good evening.